Here's problem 3018. A wire carries a current of 20 amps along the y-axis from y equal 9 centimeters to y equals 16 centimeters. What is the magnitude of the resulting magnetic field at a point x equal 12 centimeters on the x-axis? I have this marked as hard, but maybe it's not as hard as we think. So let's take a look at it. Let's imagine here's 9 centimeters on the y-axis and 16. So we got a wire running from 9 centimeters to 16 centimeters on the y-axis, and the direction of that current then would go in the positive y direction like so. And then we want to find the magnetic field at a point that is 12 centimeters on the x-axis, or our point of consideration is P right there. And if we were to imagine lines from each end of this segment, it will look something like that. And so our leading angle for the beginning of this segment, which is theta 1, would be this angle right here. And our second angle, theta 2, would be this angle here. It would have to be the leading angle from the direction of the current pointing back to the point in question, in this case P. So that's our theta 1 and theta 2 respectively. Alright, we want to find the magnetic field at point P. That's equal to mu naught I over 4 pi r times cosine theta 1 minus cosine theta 2. Sounds good? In this case, mu naught is 4 pi times 10 to the minus 7. And the current I is 20 amps. And what is R? Well, R is the shortest distance to the line of action of the current. If the current's along the y-axis like this, then the shortest distance to that line of action is this distance right here. So that's our R right there, which is 12 centimeters. So that's all we need to consider. What is the perpendicular or shortest distance from the point P to the line of action of that current? So our R is 0.12 meters, or 12 centimeters. Okay. Cosine theta 1. Well, theta 1 is this leading angle. It's the supplementary angle of this angle right here. And if I look at that angle, the cosine of that triangle, if I consider this triangle right here, this right triangle here, I have a 9 on one side, a 12 on the other side, and a 15 on the hypotenuse. So the cosine is going to be 3/5, 9 over 15. And so the cosine of theta 1, which is a supplementary angle of that, will be a negative 3/5. And then we got minus, and now we have the cosine of theta 2. If we look at the other triangle, this triangle right here, we have one side that's 16, another side that's 12, and then the hypotenuse is 20. So the theta 2 is the supplementary angle of this angle right here, and hence that angle is going to have a cosine of 16 over 20, 4/5. So the cosine of theta 2 will be the supplementary of that, which would be a negative 4/5. Okay, so these 4 pi's cancel out, and so far we have 2 times 10 to the minus 6 over 0.12. We're going to have a negative 3/5 plus 4/5, which will give us 1/5. So this is 2 times 10 to the minus 6 divided by 0.12 times 1/5, which would be divided by 5. What does that give us? 2 to the minus 6. That gives me 3.33 times 10 to the minus 6 Tesla. So that is the magnitude of the magnetic field at point P And if we have this current going from 9 centimeters to 16 centimeters along the y-axis, if we point our thumb in that direction along the y-axis, then our fingers will curl into the page at point P. So this field will be going away from us into the page at that point. So that's our magnetic field, 3.33 microtesla into the page at point P.